All right, good morning, everyone. How are you doing?
Good
Good
morning,
morning,
sir.
sir.
Morning. Okay, so you can all hear me clearly. That's good. All right, so let's get to that assignment which I had given to you. So I think on Monday or Tuesday, I think I'd given you an assignment, a simple program, in which you had to pass a two-dimension array into a function, right? And compute a simple addition. Right, so I hope you have done it. In case if you have faced any problem or you are still not able to figure out what has to be done, and still if you haven't done it, then while I was waiting for you to join, I just wrote that program for you. Okay, so I'm going to show that program to you, briefly discuss it, and then we'll move on to the topic for the day. So just to have a small recap on what this program was all about, I had asked you to do a simple assignment to create a simple two-dimension array. I'd given you the dimensions, which were 2 and 5, and I had also told you the values that you need to initialize into them. So that was 1, 2, 3, 4, 5, and 5, 4, 3, 2, 1. And you had to write a function whose name was add, and that function should take 3 arguments, right, or parameters. The first argument would be the array, right? The entire array, the two-dimension array. The second argument would be the first dimension, which is basically the 2 value here, and the second dimension would be the 5 value here. So 5 basically signifies the number of columns, and 2 signifies the number of rows in a two-dimensional array, right? Then I had asked you to call the add function in the main function and display the sum of all the array elements. So your output should have been 30, which is 1 plus 2 plus 3 plus 4 plus 5 plus 5 plus 4 plus 3 plus 2 plus 1. Okay, so in case you have had a problem in doing this program, or if you're still not very clear about what we need to do, you can go through the small code which I have written just now. I'll just show it to you. That's it. Okay. So please go through this code, which is the solution for the program which I had given to you. It is a very simple program. If you look at this, let me just quickly run through this code so that those people who join in late or those who are not able to understand can easily do it. First important thing in this program, which everybody knows it well, is that I have declared a header file here. The header file is stdio.h because I'm going to use the printf function in this case. So that's why I need the header file. All right, so this is going to be the prototype of my function, add, right? Let's not talk about this function right now, but let's get into the main. So according to the problem statement which I had given to you, you were supposed to declare an array, an integer array. So here I am declaring an integer array. So this line is basically showing that an array declaration has been done. And what are the dimensions of that array? I told you that it's going to be a two-dimension array, right? 2D array. So one dimension is this and the second dimension is this. And I had also asked you to initialize the values in these two-dimension array, right? The values that also are specified, and here are those values. So in one straight line, I have created an array and I have also initialized these values in an array. So these values are going to get stored in this array as 1, 2, 3, 4, 5, and then again 5, 4, 3, 2, and 1. Okay, so all this initializing as well as declaring the array has been done in this line. Okay, what am I doing in the second line? I'm doing nothing, but I'm printing the sum of all this. So 1 plus 2 plus 3 plus 4 plus 5. I'm doing the sum of all of these values which I have initialized into an array. And for that, I have used a function here. What is this function going to return? It's going to return the sum of all the array elements. So if I use this function here, this is going to give me an integer, because I have a format specifier for an integer here, that is %d. So this function, that is add, is going to return an integer. Second thing, what this add is going to take, it's going to take list. What is this list? List is the array here, right? List is the array which is here. The same list is going to be, kind of input as an argument or a parameter into this function. The second is the value 2 and the third is the value 5, right? So second is the value 2 and the third is the value 5. Why 2 and 5? Because 2 signifies the 2 and 5 signifies the dimension of the array, right? So we are talking about a 2-dimension array. So 2 is basically your row and 5 is the number of columns. Okay, sorry. All right, let's get back to it. Now, since I have used a function here, since I have actually defined a function, it's a user-defined function, I need to write the body of the function. So the body of the function is written here. However, since I have used the function before the body has been declared, right, I have to write the prototype of the function in the first line and give this information to the compiler, and this is basically the prototype of your function which I have written. I have purposely written the prototype here just to kind of revise with you. I could have straight away taken this entire function and put it here, then this prototype was not required. So since I'm using this add function before the body of the function has been defined, I need to write the prototype. And what is the prototype? The prototype tells me what is the name of the function. So the name of the function is add. Okay, the name of the function is done. What is this function going to return? This function is going to return an integer. So do we have an integer here? Yes, that's the prototype of my function. What is this? The first parameter which is going into this function, it's an array. What kind of array? It's a 2-dimension array. So here I have an array, 2-dimension array, right? Second is one integer variable, and third is again an integer variable. So here I have integer max1 and integer max2, right? Now I don't need to use the same name here as list. I told you in the previous class that in the prototype and inside the function, I can always change the name of the variable. It need not be the same variable that I use. So in place of list, I can write ARR and ARR here. Okay. So now I have to define the body, right? And in the body definition, I have to actually write the piece of code. So what am I doing here? So what this function is going to do, this add function is going to do is, as soon as you come across this line of code, it is going to call this function. It's going to call this function. In the sense, it is going to come to the body of this function. So when it comes to the body, it along with the function call, what it brings these three values. First one is an array, which is this one. The second one is the number 2, which is going to be stored into max1, and the third one is going to be the number 5, which is going to be stored into max2. In this case, we are passing these arguments as values. Okay, so a copy of 2 and 5 are going to be here. So a copy of all the three are going to be here. A copy of this array is going to be put into this list. A copy of this 2 is going to be put into max1, and a copy of 5 is going to be put into max2. So what am I doing inside here? Now I have taken two temporary variables I and j, and you know it very well. Why am I taking this I and j? Because I need to run two loops, one to process the row and the second to process the column. So I need two variables here, right? And the third variable which I have taken is sum, and I have initialized it with 0, and this is basically going to be the value which is going to be returned by this particular function. So let's process this code. So in the first line of code, what I've done is I've written a for loop, right? This for loop is going to iterate, along the row, right? So the value of this starts from 0. Max1 is nothing but 2. So this will be I will be less than 2 and I plus plus. So what it's going to do is it's going to iterate through these two rows. So it's going to start with first row. Then in the second loop here, it's going to iterate through the column. So it's going to go from j is equal to 0 to j is less than 5, because max2 value is being returned is 5 here. So this is going to be 5 here, right? So with I value 1, j is going to have value from 1 to 5. Sorry, from I value 0, j is going to have value from 0 to 4. That means 5 times, right? So this line of code is where the sum is being calculated. So initially the value of sum is 0, right? Now I and j, by this I can start accessing the values of an array. So in the first run of the loop, the I value will be 0. So this is going to be something like list 0 and 0. So list 0, 0, 0 is going to be the first element, which is 1. So sum was initialized as 0. So this is going to change into 0 plus 1, which is equal to 1. Now the j value is going to become 1, but the I value is going to remain 0. So I value is going to remain 0. That means we are still looking at the first row. But now, since the value of j changes from 0 to 1, we are looking at the second element of the first row, which is 2. So this becomes 2, and already our sum was 1. So 1 plus 2 becomes 3. Now we go to the third iteration of the second loop. So in the third iteration, we get value j is equal to 2. So when you go j is equal to 2, I value is still 0. So this becomes 0 and 2. So 0, 2 means we are still looking at the first row, but now we are accessing the third element, because this is the 0th element, this is the first element, and this is the second element, and this is the third element, right? So in this case, 0, 2 means we are looking at this number 3. So what is going to be the value returned by list I j when the I value is 0 and j value is equal to 2? We're going to get the number 3. This number 3 is going to be added to the previous sum, which was 3 already, 2 plus 1. This way, all these elements will get added one by one, and finally, this loop will complete, and then what this function will return is the final value of sum, which is going to be 30. Now this is going to be returned all the way here, right? So this is going to get 30, which is going to get placed into this placeholder, and what your output is going to be is the sum is equal to 30. Okay, so this is a simple explanation of the assignment which I had given to you. So if you have not done it, or if you have a doubt, please try this again, and this time you can refer to this code which I have written. You can run this code, you can write it, but try to understand this code first, and then try to write it in your own language, in your own way. Okay, so any doubts on this, or you have any question or queries related to this?
So just a
Or if you
question.
can see the code clearly? Yes,
Yes, sir.
please.
Sir, the process through
Yeah,
which
tell
you have
me.
done,
What's the question?
I did and I got the result, but I just tried to solve it
Yeah.
by giving the independence to the user, what he want to put, how many rows and columns he want. When I tried by that
Yes,
method,
that's fine.
I
That's
just
fine. Yeah, yeah, yeah.
sir, I just got stuck on that particular
Yeah.
line. It's
When you
showing that
tried through that method, what happened?
sir, I just couldn't. Can I share my
You
screen,
couldn't
sir?
do it. See,
Or I just send the code
the
to you.
point is, I see the point is, if you
Yes, sir.
try to give these values to the user,
Yes, sir.
right? You're trying to input these values from the user, right?
Yes, sir.
That is not possible because you are trying to allocate this array statically. This is a static allocated array. If you want these to be supplied by the user, that means you have to create, the user is entering the values at what? At runtime, isn't it? When the program
Yes,
is
sir.
running, that's the time the user is entering the value. Are you able to understand?
Yes, sir. Got it.
Yes. So we are trying to create the array. According to you, we are trying to create the array at runtime.
Yes,
So
sir.
when you are trying to create the array at runtime, you have to dynamically create it. You can't
Okay.
create it like a static way. That's the
Okay.
reason you can't supply values in this program and make it work. Now, did you understand the problem?
Yes, I got it. Got it, sir.
Okay.
Thank you, sir.
Okay, good. Great. Any other questions from anyone related to this problem? No? If you have no questions related to this, then we can start with the topic which I had planned today. So can I start? Can you give me a response, please?
Sure, sir.
Okay, great. Fine. So today we're going to start with something called as recursion. Okay, recursion. All right, what is recursion? Anybody has an idea on what is recursion? Let me first try and get it from you. If anybody knows what is the meaning of recursion. Anyone? Okay,
So
don't worry about it.
repetition.
Yes. Yes, absolutely. Recursion is basically, something happening again and again, right? Repeating it again and again. So what exactly is this recursion in your programming, right? And it's not just confined to C programming, because this is a programming fundamental class, and these concepts which I am teaching you, but I'm using C programming to teach them, but these concepts are all going to be there in any programming language that you learn. Okay, so let me just explain what exactly recursion is. Recursion is basically trying to repeat itself again and again. Now, what does it mean? It means a function can be called as a recursive function if it calls itself. Now, what is the meaning of a function calling itself? All right. Now, see, I'll write a simple, a kind of a skeleton code. Okay. So let's say I have my int main, right? And inside this int main, I am going to call a function. So I write lots of lines of code. So I have lots of lines of code. And one of the lines of code, I have a function. Let's say fn is my function, and I'm calling a function, right? So normally what happens? This function body has to be written somewhere, isn't it? Either you can write it after the main or you can write it before the main. So if you write it before the main, you don't need to write the prototype. If you write after the main, you have to write the prototype of the function, right? So this body has to be written somewhere. So let's say here is the body of this function, and this function has got lots of lines of code, right? So this, so far so good. So far so good, because I have a function, the int main. I have a function call happening at int main. This function call is going to actually take me to the body of the function, and all these lines of code are going to get executed, and then the program counter is going to come back here. That's how the normal function works. Okay, so I can return here. I'm not writing anything here, but I'm going to return something. This is going to return something back to the main program. Now I can do this inside this function. Okay, inside this function body, I can call this function once again. Okay, so what's happening here? Now what's happening here is the function is calling itself. So from the main, the function makes the first function call. So we make a first function call from the main. The control is transferred to the body of the function. All that is fine, right? The control goes to the body of the function. Now in the body of the function, the lines of code start getting executed. And once it reaches here, there is another function call. So what happens when a function is called? It returns back to the body, right? So from here, it once again goes to the body of that function, and again these lines of codes are kind of executed, and then it comes back once again to this line, and this function does another call to the same function. So what happens here is the scenario is something like this. From the main method, right, this is one function, right? From the main method, a function call is made, right? This function body is written here. This function body is written here. Now here in the function body, the same function is called once again. So what happens? The control from the main travels to the function body, and then it keeps looping here. It keeps looping here. So what is happening here is the same function is calling itself again and again and again. So this is actually going to cause an infinite loop. Okay, it's going to cause an infinite loop. So what we need to do, well, this is a property. This is a property that a function can call itself. But how can we make it useful? How can we make this property useful? That's the whole point, right? In this case, if I just use a simple recursive function, then this function is going to loop for the rest of the life. That means it's going to go into an infinite loop, and that's not something that we really like, right? So we have to use a recursive function in a very smart way. We have to use a recursive function with a condition. Okay, so in a recursive function, what you need to have is a condition. What is this condition? What is the importance of a condition? Condition is a very important property of a recursive function, because there has to be one condition where this looping is going to stop, right? There has to be one condition which is going to be checked. So this condition needs to be checked every time the function starts, keeps calling itself, right? When the function calls itself, you need to check this condition, whether this condition is satisfied or not. If it is satisfied, let it loop again. Again, you know, kind of check the condition for the third loop and keep doing it until this condition is not met. Or if this condition fails, then this function will exit and it will no longer loop. Okay, so the important point is, with a recursive function, with a function which keeps calling itself, you have to ensure that there has to be a condition, and condition is very important in a recursive function. Okay, so the first call that you make from the main method, right, the first call that you make from the main method is called as a function call. So if I have, say, a function called recurse, okay, let's write recurse, and I have some lines of code here, and I am calling this function once again inside the same function, right? And if I have my int main here, and inside int main, if I have this recurse, and what happens is, this recurse is actually, this is called as a function call. Okay, this is called as a function call. So this function will call this body of the function. Now when we go to this line of the code, it will once again call this body. Now this is called as a recursive call. It's not very clear, but it is recursive, recursive call. Okay, so when a function calls itself, it is called as a recursive call. When a function is called from the main, it is called as a function call. So far so good. Did you understand whatever I have told you till now? Then I
Yes, sir.
can,
Yes, sir.
yeah, okay.
Yes, sir.
So what I'm going to show you is how this recursion can be useful. Okay, how this recursion can be useful. All right, first thing, suppose I have a requirement of, let me take a small example, and I'll also write a small program and show it to you so that it's clear. Let's say I have a requirement of adding, say 10 numbers or 5 numbers or 4 numbers. Okay, so suppose I have, you know, in a normal program, what I will do is, suppose there is a function which I'm going to write, a normal function, right? In this function, I will take some, suppose somebody enters 5 integer values, right? So suppose he enters n is equal to 5. So I want the sum of basically the first 5 n numbers, right? N, the natural numbers, right? So what do I do? So suppose and the input is 5, then I will have to do 1 plus 2 plus 3 plus 4 plus 5. So this is the sum that I need to get, right? So in the normal programming, if I write a function, I will be doing this process: 1 plus 2 plus 3 plus 4 plus 5. But if you see here, I am actually repeating the same function, the same sequences. Like in this case, I'm just taking 1 and I'm adding 2 to it. Again, if I look at this entire, both these cases, to this I'm adding 3. Again, to this I'm adding 4. To the whole thing I'm adding 5, right? So there is a sense of recursion here, that I can try and implement anything which is happening, you know, repeatedly. The same thing is happening repeatedly. So when you have a scenario where the same thing is happening repeatedly, or the same processes are being executed repeatedly, then you can start thinking about a recursive function. Now, if I have to implement this and change it into a recursive addition process, then how do I write a function? So the function in this case will be, in case of a recursive function, this whole thing will change. So if my value entered is 1, I don't have to do anything, right? What is the sum of, if I enter the value as 1, so it's going to be just 1. The output is going to be 1. So in this case, there is one condition, that if the value entered, if n is equal to 1, if n is equal to 1, the output is going to be 1. There has to be nothing, no need to do anything in this. But in case if the n is greater than 1, if the n value is greater than 1, then there is a function which we need. And what is that function? That function is going to be nothing but you take the n value and you add the next value of n. So now if you look at it, what am I doing here is this same function, right? Suppose you're using add. So in this add, I'm going to first pass 5, and then I'm going to pass 4, and then I'm going to pass 3, and keep adding their output. So this way what will happen is I can write the same program in a different way and use recursive function call. So just to make this even more clear, let me just write a program and show it to you. Okay, so let me just take a clean sheet and write it here. So all of you, please just look at the program which I'm writing. Let me change the font color. Okay, do you have a class after this?
No, sir.
Sir.
No, sir.
No.
No,
Yeah,
sir.
whose class do you have? You don't have. Okay, fine, that's good.
No, sir, no class.
Okay, so yes, Vishal, you want to say something? No, you just raised a hand. Okay, fine. So let me just get to the screen. All of you can see my screen, right?
Yes, sir.
Yes, sir.
Yes, sir.
This board. Okay, okay, great. So let me write it then. So here is my hash include stdio.h. I've written it so many times. Now what I'm going to do is, let me just write the int main first, and then we will worry about that function later. So here is my main. So inside my main, I have taken one integer number, okay, and I'm taking another one as result. Okay, so there are two variables here. So what I'm going to do is I'm going to ask the user to enter any number. So suppose let's write scanf and let the user enter this number. Okay, so I have %d, and as you know that when you are using scanf, so you have to use and. So this is basically the number which the user is going to enter. So if the user enters 5, what we will print is 5 plus 4 plus 3 plus 2 plus 1. Okay, this is the value that will print. So that's 5 for 9, 10, 11, 12, 15 should get printed. If the user enters 3, what should get printed? 3 plus 2 plus 1. So 3 plus 2 plus 1 is 3, 4, 5, 6. Okay, so that's basically my problem. And I'm trying to address this problem, and I'm trying to implement this using a recursive function. All right, now let's make a function call. So the result is a variable which is going to store the value of the sum. That means whatever 15 or 6, this is going to be stored in result. But I need my function now. I need a function. So let's name this function. What it's going to accept as a parameter, it's going to accept this number, because depending on 3 or 5, it has to give these values. So let's pass number into this recursive function. So far so good, right? Everybody is understanding what I have written so far, right? It's a simple function call which is going to return some value, which is going to go into this result. And when you print this result, so let's print that also. So printf and sum is equal to, you know what I'm doing here, %d, and I write result here. Okay, simple. So that's it. That's my program, but the main important thing is my function. All right, so and this is going to return. So let's finish this main part. Okay, so I have used a sum here, but I have not yet written the body of this function. So since I have not written the body of this function, I need to define or write the prototype of this function on the top. So this prototype, I'm going to write it here. So here is my function. The name of the function is sum. What is this function accepting? It's accepting an integer, right? So I can write this integer. Let's write this n here, and this function also returns some integer. So this function returns an integer and it takes an integer. Okay, so I'm going to write the body of this function now. So let's write the body of this function. So in here I'm writing the body of the function. So here is my function which is going to accept n. So here this number whatever the user enters the number, that number is going to be passed into this function, into this variable n as pass by value. Okay, because we're not doing pass by reference here. Now, there is a condition. If my user enters 1, then there is no need for any recursion, right? If the user enters n value as 1, that means do we need to do recursion? We don't need to do recursion. We need to do recursion only when the n value is greater than 1 or it is not equal to 0, right? And the second thing is, when should we stop? We should stop when the n value reaches the minimum. That means it becomes 0 here. So our recursive function should only get executed repeatedly until only if the n value entered is not equal to 0. So let's write that. So if our n value is not equal to 0, then only we need to do this recursion. So what we do, we will return n, and along with that, because we have to add, right, we are going to again call this function. What is the name of the function? The name of the function is sum. But this time I am going to take and pass one value less than what the user had entered. Because when the user had entered, suppose he entered 5. So I took this 5, brought it into the function, and here I have this 5, plus I'm making another function call. So now this is hanging in the air, and this function call happens. Now here it goes back to this main here, once again here. And this time, what is the value which is returned from n minus 1? 4 is returned. So we have 5 and plus we have 4. And after 4, again, this part is called again. So it comes back once again here. And then after 4, what is the value here? 4 minus 1, 3. So the value which is returned, actually it's n, which is 3 here, and along with 3 we are also calling this function again with 3 minus 1. So again this function is being called here, and this time it's going to be 2, and similarly 1, and finally it ends. So when it ends, that means we put a condition here that if the value is 0, right, if the entered value is 0, that means what we need to do is just return n. So if the user enters 0, right, the answer will be 0. Okay, if the user enters 0, the answer will be 0. But if the user returns any other value other than 0, then it will enter this loop. And once it enters this loop, it will keep executing again and again. So are you able to understand what's happening here?
Yes, sir.
Yeah, so what's
Yes,
happening
sir.
here is I'm calling this function again and again. So the same function is being called again and again. So if you look at a dry run of like what exactly is happening, so here is my main. Okay, here is my main. Okay, inside the main, so my return in this recursive function is what? It's return n plus sum of n minus 1. So what's happening is the first time the value that is being entered is 5. So 5 is going to be here. This is my body of the function, right? So the body of the function, this is the return statement. So 5 is going to be returned here. And along with the 5, I have not yet completed because I have made another function call, before returning the value. So this function call will again enter the body, and what value is going to be returned back? From this, I'm going to get 4. So here it is 5 plus 4. Now after 4, again I have plus some n minus 1, right? So what is this n minus 1? In this case, n minus 1 will be 3. So this will be returned once again back to the same function. And this time what is going to be returned as 3. So here it's going to be 3 plus I again, have some n minus 1. So in this case, what is going to happen? 2, right? And then again a function call. So at the end of it, when I complete all my n values, I am going to get 5 plus 4 plus 3 plus 2, and last one 1, and all this value is going to be returned back to the place where I made this function call. So here that 5 sorry, 1 plus 2 plus 3 plus 4 plus 5, this which is 15 is going to get returned here. Okay, so this way I can use a simple recursive function and call the function many number of times within itself. Now, this is a simple example of how you can add 5 or 6 numbers, but you can use this recursive functions in many different ways. Okay, like for example, I don't know whether you know, do you know what's a factorial of a number? So if you know the factorial of
Yes,
a
sir.
number, a factorial of a number, yeah, you know it, right? So factorial of a number is what? So suppose
Yes, sir.
if I have a number 5, what is the factorial of 5? It's 5 into 4 into 3 into 2 into 1. That's the factorial of 5. Right. So in this case, if I have to, now I can see that there is the same steps are happening again and again. So I can change this program also to actually write this program. I can change it to, print the factorial of any number. Okay. So all I need to do is when I'm returning, I need to return into whatever is the name of the function. So if it's factorial, then factorial n minus 1. Okay. But that's it. So you just need to change this line, and there is one more property that factorial of 1 is 1. So factorial of 0. So factorial of 0 is 1, right? What is the factorial
Yes,
of
sir.
0? Factorial of 0 is 1. So that's one
No.
additional, kind of condition that you need to put. So you need to change this line of code that if n is equal to 0, return 1, else start doing this factorial stuff. Okay, so you can write factorials. You can, if you know Fibonacci series, you can implement your what you call this recursive functions using on Fibonacci series. I don't know, have you done what are the stuff that you're doing in your lab? Can you please give me a recap of what you have been doing in the lab? What programs have you been writing in the lab?
So currently function is
User
going on.
defined function.
Function currently going
Okay,
on.
so you're doing user-defined function. Okay, function is currently going on. So
Yes, sir.
anyway, so you've done functions as theory. So you try to write this recursive functions in the lab when your functions are going on, right? This is also a user-defined function, but this function is a recursive function.
Yes,
So
sir.
you have any queries on this recursive function? Anyone? Okay. No, you don't have any queries. Okay. So you
No,
need to
sir.
write these programs. Okay. I have discussed two programs here. One is to add, 5 plus 4 plus 3 plus 2 plus 1, and I've also discussed the factorial. So today or tomorrow, whenever you have the lab, please try and write these programs yourself. Don't look at this screen. You can refer to it later, but don't copy it from here. Try to understand and write it yourself, and
So just a
then
question.
you will become more confident. Yeah, yeah,
So sorry for the interruption. So like let's suppose we are
yeah,
just doing some problems so using functions. So for
yeah.
operations for different operations we perform the different functions. Like I just want to calculate maximum and minimum among five numbers. So I have to write the two functions. But sir, I wanted to calculate the maximum and
Yes.
minimum
No, you
of
can
that
you
five
can you can you can
in a single function.
you can write it in the same one. Yes, you can do that, because once you have the function, it's basically, you can, once you are taking those 5 values inside a function as an input, inside that you can write logic. You can write it in one function, you can write it in two functions, no problem. Like for example here, in case of any program, addition, subtraction, you can write it as two separate functions, or you can write one function as arithmetic and do both inside that. No problem. You can do it. Okay,
Yes,
you can do it. There's no problem at all. But what
yes,
happens is, why we are writing functions? We are writing functions because we are trying to make our program very more modular. That means we are trying to, kind of partition our program into small bits which are easy to understand. So which
no, sir.
more number of people can use. So
So
suppose,
that's good.
yeah.
I just wanted to.
So
I'm
suppose you are
using
writing,
my function.
yeah.
Yes, sir. Yes, sir, continue.
Okay. Okay.
So
No, you can do it. You can do it. You can do it. There's no problem. You can do it. You can do both. But for example, suppose I need to use a function where I need to find only the minimum value of a list of numbers. Then I can't use your min max, because your min max is one function which returns both min and max. But I need only min. But so suppose if you've written two functions, one for min, one for max, then I can use your functions, right? So if I can make it into smaller functions, then it is more reusable. If I integrate more than one kind of concept into a function, then although yes, it's useful, but probably it may not be useful in some cases. So that's all.
So, sir, which is the most suitable or most appropriate, like using two functions or use one functions and calculate the two things?
See, for now, you have to try doing both, because at this point of time we are just learning the concepts, right? We're learning the concepts, so you should know that, okay, I can write two functions in one function, I can write two simple small functions. Now, which is more appropriate, that depends upon the requirement of the problem. If your problem is to solve, for example, if you are making a calculator application, if you're making a calculator application, so the application is a calculator application, so it is advisable that you put addition, subtraction, multiplication, division as separate functions.
Yes, sir.
Okay, but if you have a problem to solve wherein you have to do a computation which involves addition and subtraction, then you can use one function and put both in that.
Yes, sir.
So depending on the requirement, you'll have to, kind of, decide on what will be the strategy. For example, if you look at, a recursion, right? If you look at recursion has its advantage as well as disadvantage. Okay, recursion has both advantages and disadvantages. Now, recursion actually makes the program very elegant, right? It's kind of but what happens is it slows down a little bit. It slows down because there's so much looping happening. The loops are going, you're looping again and again and again. It's basically, you're traveling the distance once again, many number
Yes,
of times. So what happens, your
execute
program will become little slow.
the
So
execution time
if you,
increases.
yes, your execution time increases. Although your program looks very elegant, but your execution time increases because looping actually takes a lot of time. So recursion is slow. So if you want a faster program, you should not use recursion, use a loop and try to do everything in a loop. But if you want it to be elegant, but it's an important concept, and mainly in data structures and algorithm, when you study data structure and algorithm, right? For example, I don't know whether you know it or not, but if you're studying trees, concept of trees, and you're doing trees, traversal and all that stuff, that's the time when you find that, okay, recursion is going to actually make my life simpler. So everything has an advantage and disadvantage, and you have to choose it depending on the requirement. Okay, and the situation. Yeah, absolutely. Fine then. We can, I think it's almost time. So I think we should start giving the attendance now. Yes, I have enabled the attendance link. Please give your attendance and then you may leave.